Almost a decade after the 2010 Deepwater Horizon disaster,
there we go.
Hundreds of scientists are assessing the impact of the largest offshore oil spill in U.S. history. What follows are some of their stories, intimate portraits of research, innovation, and discovery.
I'm Chief Scientific Officer for the Gulf of Mexico Research Initiative. The responsibilities are to coordinate communication between the scientists, all the researchers, the board, and with BP. So I'm the intersection of a lot of information and make sure it gets to where it needs to be. When I was a little boy, my grandfather would take us fishing every summer on the Chesapeake Bay, and we spent a lot of time playing on the water, catching fish, catching crabs. And there were a lot of ponds near my house, so I had just an intrigue with the aquatic environment, and particularly fish. And that turned into the hobby of fly fishing for trout in Maryland. Then it turned into a surf fishing hobby with my father in Ocean City, Maryland. So I've always been very intrigued with fish and led me to a career in fisheries biology.
Years later, on April 20th, 2010, Dr. Wilson's career path was dramatically changed by the nation's largest offshore oil disaster.
At the time, I was Sea Grant Director when Deepwater Horizon occurred, and frankly, I was surprised it had taken so long for an incident like that to occur in the Gulf of Mexico, given that there were some 4,000 wells at the time, and it was inevitable an accident like that might happen. At the same time, I thought technology would shut it down very quickly, and initially I was not concerned about the environment because the Gulf of Mexico has naturally been releasing oil for millennia, and the system is very adapted to handling that kind of insult.
Shortly after the oil spill, BP provided $500 million over 10 years to the Gulf of Mexico Research Initiative for basic research. That was when Dr. Wilson was appointed GoMRI's chief scientist.
There's a collection of science that's been funded that represent the various disciplines of oceanography. They touch on the physical oceanography, that's the movement of currents, movement of water particles, both subsurface and surface. There's a large research investment in chemistry and a large research investment in ecology. So those are the three basic components of oceanography, and we have had a number of really interesting findings across all three of those disciplines.
But what made GoMRI's approach truly innovative was having grantees work in collaboration with other scientific institutions.
And go!
When they established the rules for how the money should be handed out, they wanted to make sure that the funds were distributed across competitive institutions that had research capacity. And that forced institutions and disciplines to work together that had never worked together before, and it's been really rewarding to watch those teams grow together to become colleagues and tackle problems and discover synergistic research findings that would not have happened had the money not been forced to be mixed across research groups. If you think about a droplet of oil moving up through the water column, it's going to encounter a number of different disciplines as it begins to decompose. There's bacteria digesting the outside of it. There is a chemical process involved in that decomposition. As a droplet of oil rises to the surface, sunlight's going to hit it, wind and waves are going to hit it. So you have to understand physics, you have to understand the effect of solar radiation and biological decomposition of that oil droplet. So no one discipline can really determine what's happening to that oil droplet unless everybody's working together at the same time. The research board thought it was so critical to fold outreach into the scientific process, so all the consortia had to have a comprehensive outreach plan for them to put the science out into the public's eyes. And that has actually created a really interesting community of outreach specialists across GoMRI that now work together to build larger outreach tools. I think one of the greatest accomplishments of GoMRI is its production of graduate students. By the end of GoMRI, we will have touched over 1,500 graduate students that will go on to be the next generation of scientists that will understand what collaborative research is all about.
As a young boy, Dr. Wilson was drawn to the magical wonders of the ocean. Today, he's deeply concerned about them, as well as the future of his grandchildren.
I'd like to think that my grandchildren will be enjoying an era of less dependence on hydrocarbon-based fossil fuels for power. I'd like to think that we'll have better solar, better wind, better hydro plants. I'd like to think that the work that we're doing will lay the groundwork to be more diligent of protecting our ocean environment and making sure that we're not adding pollution to the point that we're affecting the algal populations, which will affect the microscopic organisms that feed the higher trophic levels and provide resource and food for mankind.
Today, the scientific community is working together to push the boundaries of what they've learned about oil spills and what still needs to be discovered.